Okay, so we're going to look at the question, determine the cube roots of -8. Now, if you look at what's the cube root of -8, you'd probably straight away go, well, I know that, it's -2, because cubed root means what number multiplied by itself 3 times gives us -8. Well, -2 times -2 times -2 gives us -8. So you'd be thinking, well, the answer is just -2. Well, it's true if we're just looking at real numbers. But if we're looking at complex numbers as well, then there's actually more than one solution. Yes, one of the solutions is -2, but there's a couple of other solutions as well, which we're going to look at. Okay, to start off, we will look at how do we write -8 as a complex number. Okay, so -8 is equal to 8 cis pi. Now, if you're unsure where that's coming from and how that works, well, a diagram will probably help answer this question for you. Now, remember, the real component is on the x-axis and the imaginary component is on the y. Now, if we're looking at -8, -8 is over here. Okay, and if I look at it putting in mod arg form, as I've got right here, 8 cis pi, then the modulus is 8. So it's a distance of 8 from the origin out to here. And the argument, the angle from the positive x-axis or positive real axis, rotating back in an anti-clockwise direction, is going to be pi in radians. Okay, so -8 is the same as 8 cis pi. Right? Now, there's another way that we could write -8. There's actually quite a few that we could write, ways that we could write as a complex number, this 8 cis pi. So let's have a look at some of those combinations. All right. I could also write it as 8 cis 3 pi's. So there's 1 pi, 2 pi's, 3 pi's, and we end up at the exact same place. Okay, so I could use that angle instead. I could use a variety of different angles and still arrive at that same location. Okay, I could use 5 pi as well. If I went around with 5 pi's, I'd still end up with that same solution, that same value of -8 on the real axis. Now, instead of that, I could also go in the negative direction. I could go -pi, okay, and I could go -3 pi, and I'd still end up with the same value, still the same complex number. So another way we could write 8 cis pi is in terms of 8 cis pi plus 2k pi, where k is an element of integers, all the integers, positive and negative integers. Okay, so what I'm saying here is this angle can be pi plus 2 times whatever whole number we want, okay, or negative number as well. And that will give us all these options, all these possibilities that we just talked about in this diagram. Okay, now we are interested in the cubed root of 8 cis pi. Okay, the cubed root, which is the same as to the power of a third. All right, so I'm going to write this other part, the second part, to the power of a third as well. Okay, now using de Moivre's theorem, which we know, I can say that this is equal to, with the modulus, I can just say, well, that's 8 to the power of 1/3. All right? And then if I'm looking at the argument, because it's to the power of 1/3 here, that's the same as multiplying the argument by 1/3 or dividing it by 3. Okay, so if I divide it by 3, I'll end up with pi on 3 plus 2k pi on 3. Okay, and remembering k is any number that I want. Can be, as long as it's a whole number, so 0, 1, 2, 3, 4, 5, 6, or it could be -1, -2, -3. Right? So if I look at those different values, well, first of all, 8 to the power of 1/3 is going to be 2 cis. And I'm going to look at a couple of different values for k. So if k is equal to 0, then we'll end up with 8 cis pi on 3 plus this 0. Okay, so that's one solution. The next solution could be 2 cis, and my new angle would be, I'm using different values for k, so if k was equal to 1, I'd end up with pi on 3 plus this 2 pi on 3. So that just gives me 3 pi on 3, which is the same as pi. Okay, so that's my second solution. Now I've got another solution that I could have. I could say k was equal to 2. Right? And if I did that, I'd end up with 2 cis, and I'd have pi on 3 plus 5 pi on 3. Sorry, not 5 on 3. Pi on 3 plus 4 pi on 3, which gives us 5 pi on 3. Okay, so I'm just looking at all different values for k. Now I could keep going. I could keep adding in more and more and more, but if I did, I'd end up with an overlap anyway, which I'll just demonstrate in a moment. And I could also look at situations where I was using negative numbers, but again, I'd end up with some overlaps here. So I'm not going to do any more than 3. I know because it's a cubed root from experience that it's going to be, I'm going to have 3 solutions to this problem. Okay, so if I work out 3 solutions, as long as there's no overlaps there, then I've got my 3 solutions. Now, we also know that when we're doing this, we must write the argument, okay, must be between pi and negative pi. Now, if I've got 5 pi on 3, that's larger than pi. So I need to fix that up and write it in terms of, well, it has to be in between pi and negative pi. So I'll leave these solutions as they are, 2 cis pi on 3. This one's going to be 2 cis pi, okay, and the last one is going to be, if I think of it in terms of being between pi and negative pi, I might even just draw a little diagram here, 5 pi on 3, okay, so from here to here is 3 pi's on 3, and then I need another 2, so I'm going to end up over here. If I had 6 pi's on 3, that's 2 pi, so that's a full revolution. So this angle between the nearest x-axis and that line there is actually pi on 3. Okay, and because I'm rotating in a clockwise direction, it's like negative pi on 3. Okay, so I can write this 2 cis 5 pi on 3 as being 2 cis negative pi on 3. Okay, and they're my they're my 3 solutions that I've got for this. Now, remember what we're trying to find here. We're trying to find the cubed roots of negative 8. All right, so if I wanted to verify this or check the reasonableness of my result, then what I would do is just simply put each one of these answers to the power of 3, because the cubed root is the opposite to putting it to the power of 3. And if I do that, you'll realize that I'm putting 2 to the power of 3, and then I'm multiplying the angle here by 3 using de Moivre's. Same idea with the rest of them. Okay, I'll put that to the power of 3, 2 to the power of 3, and then I multiply this by 3. All right. Same here, to the power of 3, 2 to the power of 3, and then multiply this by 3 as well. And what you'll find is all the answers that we get from doing that will give us negative 8. So using these 3 complex numbers, they are the 3 cubed roots of negative 8. All right, I hope that helps. See you guys.